SN1 mechanism. Tertiary haloalkanes undergo SN1 mechanism. The reaction involves two-step mechanism. Compared to SN2, primary haloalkane undergo SN2 mechanism, and the SN2 mechanism reaction involves one-step mechanism only, but in SN1 mechanism, the reaction involves two-step mechanism. It is first-order kinetics. The rate is equal to K concentration of haloalkane only. If we compare to SN2 mechanism, rate equal to K concentration of haloalkane and the concentration of nucleophile. But in SN1 mechanism, rate equal K concentration of haloalkane only. So for example, this is a chemical equation. React with water to produce alcohol and HCl. The rate equal K concentration of only haloalkane. We don't consider the nucleophile concentration as we do in SN2 mechanism. So it depends only on concentration of haloalkane. SN1 mechanism involves two-step mechanism. The first step is a slow ionization to form a carbocation. So the formation of carbocation is a slow reaction. The second step is a fast attack on carbocation by a nucleophile. Means the second step, carbocation attacked by the nucleophile, is a fast reaction. So step 1, formation of carbocation. This is the haloalkane. Br is more electronegative than carbon. This what makes this Br delta minus and the carbon delta plus. So when Br has higher tendency to attract electrons towards the Br, so the Br use these two electrons in this one bond to become its lone pair, leaving the carbon becomes carbocation because it has no electron from this bond anymore. So this is the formation of carbocation, and the step is a slow step. The formation of carbocation is a slow reaction. Second step, reaction of carbocation with nucleophile. So the nucleophile, which is electron rich, attack the carbocation. We see is electrophilic site. This is the first step. Nucleophile attack carbocation is a fast reaction. So this nucleophile use its lone pair, two of the electrons, to form bond with carbon. So this is a bond from two electrons of the nucleophile. The third step is, we know that the product is alcohol, so we need to get rid of the hydrogen. So this step is called deprotonated of water. So we know that when this nucleophile use its lone pair to form bond with carbon, leaving the oxygen plus, means electron deficient. And another nucleophile compound, water, the same nucleophile, use its lone pair to form bond with this hydrogen. Because when we compare oxygen and hydrogen, oxygen is more electronegative, so hydrogen less electronegative, so delta minus delta plus, if you compare the electronegativity. So that's why this nucleophile attacks the hydrogen, so use its lone pair to form bond with hydrogen, leaving 2 electrons in this bond. So due to the positive of the oxygen, the electrons from the bond is transferred to the oxygen, making the oxygen having stable 2 lone pair again. And the side product is H3O+. Because the water, the nucleophile, receive 1 hydrogen, so H3O+. This is the mechanism for SN1 mechanism. The order of reactivity in SN1 mechanism. The higher the number of alkyl group, the higher the rate of SN1 reaction to happen, because this mechanism involves the formation of carbocation. We know that the higher the number of alkyl group in carbocation, the more stable the compound is. So that's why the higher the number of alkyl group, the higher the rate of SN1 reaction to happen. So this one, methyl, no alkyl group at all, so least stable carbocation. For this one, tertiary haloalkane, it will have tertiary carbocation in the mechanism, so it forms the most stable carbocation because it has the most alkyl group. Alkyl groups enhance the SN1 by stabilizing the carbocation intermediate. We've learned in the topic previously that carbon is the electron donating group. So, alkyl groups stabilize carbocations by donating electron through this sigma bond. The single bond, we call it sigma bond. So this is inductive effect. Therefore, highly substituted carbocations are more stable and more reactive towards SN1 mechanism. It means SN1 mechanism prefer higher number of alkyl group, so it will be less likely for SN1 mechanism to happen in primary haloalkane. It won't happen in primary. So primary will prefer SN2 mechanism, but tertiary haloalkane will prefer SN1 mechanism.